Alright, so let's deal with this question of why do stars appear to rise and set. Now, of course, hopefully you know they do not truly rise and set, but they only appear to. And we have enough information now from the celestial sphere model to help understand this. The Earth rotates on its axis once per day, and when it rotates, it goes from west to east. So because it's rotating in that direction, the celestial sphere and all of the stars appear to rotate in the opposite direction for an observer stationed on Earth. So the stars appear to circle from east all the way around to west. Then if a person is standing on the planet, they will see the stars move and make great big circles, and the center of that circle will be the North Celestial Pole. Now there's a star that is close to our North Celestial Pole, and it's called Polaris. That's the North Star. It's not the brightest star in the sky. That's a common misconception, but it's not. Everything rotates in a big circle around that polar axis then. Alright, so we have our view from Earth. The stars that are near the North Celestial Pole make their big circles, and those are called circumpolar stars because they never get below the horizon. So a circumpolar star is a star that never sets. It's always above the horizon. Now you may not be able to see it when the sun is up and it turns the sky blue, but nevertheless it is always going to be above the horizon. So circumpolar stars never set. Now, there's another set of stars that are below the horizon. So a star that is below your horizon, well, that one's never going to rise. So if a star is, for us, if a star is close to the South Celestial Pole, well, that star never appears to rise. So circumpolar stars never set. Stars below your horizon, close to the South Celestial Pole, never rise. But then you've got all of the stars that are in between those two extremes, and they are going to appear to rise in the east and then set in the west. Okay, so here's a good question for you then. You've got a drawing here, you got an image here of some nice rock formation, and then you've got a pattern of stars. Now this is a long exposure photograph. Somebody went outside, opened the camera lens, and just let it go for hours at a time, and it created these streaks. So those streaks are actually the positions of the stars over time. So the question is, what is the arrow pointing to in this image? Okay, your choices are, well, it's pointing to the zenith, or it's pointing to the North Celestial Pole, or it's pointing to the celestial equator. Okay, pause if you need to. See if you can figure out the answer before you go on. Alright, well, it's actually pointing to the North Celestial Pole. That bright little streak that you see there, that is Polaris. The little bright streak that the arrow is pointing closest to, that is Polaris. So you can see it's not exactly at the North Celestial Pole. Now all of the other stars then appear to make great big circles around the North Celestial Pole, and some of those circles are above the horizon, so those would be circumpolar stars, but others of those circles go down below the horizon. Those would be intermediate stars between the North Circumpolar and the southern stars that are below the horizon and close to the South Celestial Pole. Okay, so they appear to rise and set there. Alright, so we've dealt with that question, why do the stars appear to rise and set? Now let's move on. Why do constellations we see depend on latitude and time of year? Okay, well, here are the answers. They depend on latitude because your position on Earth determines which constellations remain below the horizon. But they depend upon time of year because Earth's orbit around the sun changes the apparent location of the sun among the stars. Okay, now those are the answers, but let's explore each one of those a little bit better now. We'll begin with a review, though, about coordinates here on the Earth. Let's define latitude and longitude here quickly. The latitude is an angular measurement of how many degrees north or south of the equator a location is. So here in Tyler we are around 32 degrees north latitude. Longitude is actually the number of degrees that that a location is either east or west of what is called the prime meridian. Now, the prime meridian was agreed upon ages ago to be a line that runs from the North Pole to the South Pole. So it's a meridian that goes from the North Pole to the South Pole, and it runs through Greenwich, England. And we will define now longitude in terms of that will be the 0 degree line, and then we'll measure things from 0 to 180 degrees east or 0 to 180 degrees west. Now, here in Tyler, we are approximately 95, 96 degrees west of the prime meridian. What you see here is a person that is standing on the Earth's North Pole. Now, standing on the Earth's North Pole, if you extend the line straight up, you run into the North Celestial Pole. Alright, but the North Celestial Pole is going to be at the zenith for this person. Alright, and on the horizon for this person is going to appear the celestial equator. Now, as the Earth rotates, and remember, the Earth rotating in one direction makes the celestial sphere appear as if it's going in the opposite direction. That's going to make the stars appear to move in great big circles around the North Celestial Pole. So for this observer at the Earth's North Pole, none of these stars are going to dip below the horizon. That means that these stars, all of the stars that are north of the celestial equator, are going to be circumpolar for this observer here. They'll never get below the horizon. Okay, but for an intermediate latitude, let's say one like this. This is 34 degrees south of the equator, of Earth's equator. Okay, so you've got a little person standing there once again. Now, their zenith is pointing off upwards into space. So there, that's up to that person. And if that person is at 34 degrees, well then, let's see, the North Celestial Pole is going to be below their horizon, so they cannot see the North Celestial Pole. However, they could see the position of the South Celestial Pole, and look at this. The South Celestial Pole is going to be 34 degrees above their horizon. So whatever your latitude is, that's how many degrees above your horizon the celestial pole is going to appear. Now let's go back to the person at the Earth's North Pole, and remember, the zenith is where the North Celestial Pole is, and that is 90 degrees. So what is your latitude if you're at the Earth's North Pole? And the answer is you are at 90 degrees north latitude. So again, the North Celestial Pole appears to be your latitude above the horizon. So for us here in Tyler, we are at approximately 32 degrees north. How many degrees above the northern horizon would the North Celestial Pole appear to us? And the answer is 32 degrees. So the altitude of the celestial pole is always equal to your latitude. The North Celestial Pole, the North Star, which is Polaris, is 50 degrees above your horizon and it's due north. The question is, where are you? Are you on the equator? Are you at the North Pole? Are you at 50 degrees north latitude? Are you at 50 degrees east longitude? Or are you at 50 degrees north latitude and 50 degrees east longitude? Think about it for a minute. You are going to be at a latitude of 50 degrees north because the North Celestial Pole is 50 degrees above your northern horizon, so you must be at 50 degrees north. Okay, now the other part of that question. Why do the constellations we can see appear to vary throughout the year? And the answer is here in this drawing. As you can see here, this is a drawing of the sun in the center and the orbit of the Earth around the sun. And then if you were to look towards the sun, say at when the Earth is at February 21, you're looking toward the sun, you see that the sun is in the constellation of Aquarius on that particular time. However, if you look in the opposite direction, you can see the constellation of Leo on February 21. So at this particular time of year, February 21, you would not be able to see the constellation Aquarius because it's behind the sun. Remember, and when the sun is up, it illuminates the sky, and the sky turns blue, and we can't really see the stars. So on that particular day, even though you would know what constellation the sun should be in, you wouldn't be able to see that constellation. However, you could see the constellation Leo, and you could probably see the other surrounding constellations as well, but certainly you could see Leo. Now, as the Earth progresses around the sun, you can see that different constellations then become visible because the sun's apparent position throughout the sky will change. All right, so what have we learned? What does the universe look like from Earth? Well, we can see a couple thousand stars or so. We can see the Milky Way with our unaided eye, and each position on the sky belongs to one of the 88 constellations. And we can specify the position of an object in the sky by its altitude and its direction above or along the horizon. All right, so why do stars appear to rise and set? Oh, the simple answer is because the Earth rotates. That's why. And why do the constellations we see depend on latitude and time of year? Well, because your location on the Earth determines which constellations are hidden by the Earth and which constellations are not hidden by the Earth. So your location on the planet determines which constellations you can and cannot see. Okay, but there's the additional problem of the Earth's motion around the sun. So the time of year determines the location of the sun on the celestial sphere and therefore determines what constellations you can and cannot see as well.